Hello, welcome back. Now we are going to be looking at angles in a polygon. So we'll need to understand what a polygon is. So a polygon is a 2D shape with at least 3 sides. And then you need to know that polygons can be regular or irregular. So if the angles are equal and the sides are equal in length, then it is a regular polygon. And then in a polygon, we have what we call interior angles and exterior angles. So interior angles of a polygon are the angles that are inside the polygon, and exterior angles are the angles that are formed between a side length of a polygon and an extension. Okay, so you also need to note that an adjacent interior angle and exterior angle add up to 180 degrees. So you get to understand this more as we look at examples and as it's shown diagrammatically. So now we are going to look into interior angles with more detail. So the rule that you need to remember whenever you talk about interior angles is that the sum of interior angles is given by the formula n minus 2 times 180 degrees, whereby n is the number of sides of the polygon. So in this case, we are given a triangle as a random polygon, and if you want to find the sum of its interior angles, which are A, B, and C, so using the formula, you substitute 3 for n, and then you do 3 minus 2 times 180, you will get 180 degrees. So which means that the total sum of interior angles of a triangle is 180 degrees. All right. So you also need to note that you can find the interior angle of a regular polygon. Note that this is a regular polygon by dividing the sum of the angles, that is the total of the interior angles, by the number of angles or by the number of sides of the polygon. And then you also need to note that you can find the exterior angle first, and then you subtract it from 180 degrees to get the interior angle. So now we're going to look at an example so that we understand interior angles more. So shown on the screen is a pentagon, A, B, C, D, E, and you're asked to find the value of x. So you might as well need to pause the video, think through the question, and try to solve for x. So the first point we need to note is that this polygon we are given is 5 sides. So we need to calculate the total of its interior angles. All right, so using the formula that we learned, we do n minus 2 times 180 degrees. In this case, our n is 5 degrees. So we do 5 minus 2 times 180 to get 540 degrees, which means that the total of the interior angles of this polygon is 540 degrees. So now adding up the interior angles that are shown, even though they are shown symbolically, we will get this expression. So which means that 33 plus 140 plus 2x plus x plus x plus 75 is equals to 540. So this is basically adding all the angles in this pentagon. So now we solve this expression so that we calculate for x. So collecting like terms, we will get 4x plus 248 is equals to 540 degrees. And then if we subtract 248 from both sides, we will get 4x is equals to 292. So solving for x, we divide both sides by 4, and we will get x to be equal to 73 degrees. So I hope when you tried the problem, you're able to get the value of x is 73 degrees. If you weren't able to get the value of x as 73 degrees, you may need to revisit the notes and then try to go through the question again. So now we're going to look at exterior angles. So the rule that you need to remember is that for a regular polygon, a regular shape, the exterior angle is given by the formula 360 divided by n, where n is the number of sides. So kindly note, this is for a regular polygon only. It doesn't apply to irregular polygons. So the sum of all the exterior angles on a regular polygon, on any polygon, they'll add to 360 degrees. And then, so for example, for this triangle that is shown here, it has 3 sides. So to calculate for a single exterior angle, we will use the formula 360 divided by 3, and we will get 120 degrees. So which means that for this regular polygon, each angle, that is each angle 1, 2, and 3 is 120 degrees. Okay. And then now we're going to look at an example so that we understand exterior angles more. So we are given a quadrilateral ABCD, and we are asked you to find the size of y. So again, you might need to pause the video, go through the question, and try to solve for y. So the first thing that we need to note is that the polygon that we are given here is 4 sides. So when we calculate the total of the interior angles using the formula that we learned before, we substitute 4 for n, and we do 4 minus 2 times 180 degrees to get 360 degrees, which means that the total of those 4 angles on this polygon is equal to 360 degrees, right? So now, like we said before, we know that the sum of an adjacent interior angle and an exterior angle is equals to 180 degrees. So for in this instant, this angle plus this angle gives us a total of 180 degrees. So if you're to calculate the angle CBD, we will do 180 degrees minus y plus 48 degrees to get 132 minus y. So which means that the angle CDB, this angle here, is equal to 132 minus y. And then furthermore, if you're to calculate for the angle CAB, which is this angle, we will also do 180 degrees minus the 68 degrees, because these are adjacent interior and exterior angles. So we will get 112 degrees for this angle CAB. So now we have the figures or expressions for each interior angle, right? We found this to be 132 minus y, right? So we now have the figures or expressions for each angle in our quadrilateral. So now writing the expression or writing the equation, we add up all the angles, we get 112 plus this 90 degrees here, plus this 2y, and then plus 132 minus y is equals to the total, which is 360. And then collecting like terms, we will get y plus 334 is equals to 360 degrees. And then solving for y, we will get y is equals to 26 degrees. So I hope you're able to get 26 degrees as your answer. If you weren't able to, you might need to revisit the notes and then try the question again. Thank you for watching my video. See you in the next one.